Good day, class. Okay, for the continuation of our DH frame rules, so we will construct a kinematic diagram for spherical manipulator. So I have already here an assembly of a spherical manipulator. Okay, of the 3 degrees of freedom spherical spatial manipulator. Okay, that has a RRP configuration. Okay, so let's start by assigning the indicators and labels of our mechanical manipulator. Okay, so our first link is from the base, okay, from the center of the base up to the center. Okay, sorry. So make make it color black. So from the center of the base up to the center of the next joint. So our next joint is a revolute joint. Okay. Next, from the center of the revolute joint, so this is the center. We will our link indicator should be drawn up to the connection of the revolute joint up to the connection of the next joint, which is a prismatic joint. Okay. Then from then from there, the next link indicator is from that connection up to the end effector. Okay. So let's name or label the links. So this is link A sub 1, then link A sub 2, then link A sub 3. Okay. Next, the joint variables for the first revolute joint or twisting joint. We have a counterclockwise arrow and theta 1. Oops, sorry. For our second joint, so we will place our indicator in a broken line or in a shadow line, or sorry, it's a broken line here. This broken line projects the axis of rotation for our revolute joint. So let's erase some parts. Okay. So next is the indicator, then the name, then the label of the indicator. So it will be labeled as theta 2. Next, for the last joint, we labeled and indicated as D3. Okay. Now for the DH frame rules. Okay. Or for our DH preliminary rules, let's first choose our center of frame. So for the base, The base, the center will be located at the center of gravity for the base. For the second joint or volute joint, it will be located at the center of the second joint. Also the second center of gravity of the second joint. And also where the link A1 and link A2 cross each other. And lastly for A3, or sorry, for the center of the next frame, okay, it is at the behind of the third joint. Then for the end effector, just put it uh, at the last part of the manipulator. Okay, so the z-axis must be color light blue. So it should be the axis of rotation for the revolute or twisting. So let's put it here. This is the axis of rotation. And for the direction of translation, so the direction of translation is rightward based on the projected square or the projected direction of our prismatic joint. And lastly, for the end effector, so the practice is follow the z-axis of the frame before it. Now, let's change the thickness of our z-axis to make it more uh, so we will able to see it better. Okay, so let's put the labels of our axis. Let's put it here: z0, z1 here, okay, z2, then z3. Okay, oh, why? Wait a minute. Z2 is too small. Okay. Next, Z3, Z1, Z2, Z3. Okay, next for the x-axis, okay, roll 2. So let's choose red. Okay, x-axis must be perpendicular both to its own axis and the z-axis of the frame before it. So because x sub 0 has no z axis before it, so I will choose it. I will choose to point it to the right. Okay, still perpendicular to z sub 0, and I will name it x sub 0. Next, for our x sub 1, now we have z sub 0 before the frame of x sub 1 and z sub 1. Okay, z sub 0 is pointing upward while z sub 1 is pointing forward. So our only choice is to the right or to the left. So pointing to the right is much easier to see, and it's pointing the same with pointing to the right, the same with x sub 0. So I will choose to the right. Okay, so our label for this is x sub 1. Next, for our x sub 2, okay, so we have z sub 1 pointing to the front and z sub 2 pointing to the right. So our only choice is either top or bottom. Okay. So I will choose the bottom, or sorry, the top. I'll choose the top to make it easier for me to look at it. I will put a 2 and 3 here. Okay. Then let's put it here. Oh, let's put this here. Okay, this much easier if they are pointing at the same point and only one point. Okay, so this will be our x sub 2. Okay, for the end effector, let's see. So based on rule 2, we have z sub 2 and z sub 3 pointing to the right. So we have 4 choices, but I will choose upward. Okay. To make it easier for me to see x sub 3 and to make it the same with x sub 2 for future calculations. This will be our x sub 3. Okay, rule number 3. So each x-axis must intersect the z-axis of the frame before it. So again, this is all about the x-axis. Now, let's see the first frame, which is the x0 axis and z0 axis. So this is the first frame. So let's leave it like this because there is no z-axis before this frame. Okay. Next. The first frame or the frame 1. Okay. So there is z axis before the frame 1. Okay, it's frame 0. So to see if z axis, z0 axis is intersecting with x sub 1 axis, so let's extend this. So as we can see, z sub 0 is intersecting with x sub 1. Okay. So x sub 1 complies to our rule 3. Next, x sub 2. Now we will see if x sub 2 is intersecting with z sub 1 because z sub 1 is the z-axis before the frame of x sub 2. If we extend z sub 1, okay, at the front, as you can see, it's not intersecting with x sub 2. If we If we extend z sub 1 to the behind, as you can see, it also not intersects with x sub 2 even if we extend x sub 2. Okay, this is not intersecting with x sub 2. Okay, if you insist that this is intersecting with x sub 2, it is wrong. Okay, because remember, we are looking to our kinematic diagram in three views. We have the front view, the top view, and the right side view. Now you are looking it in isometric view. You are both looking at it at those three views. Okay. If you try to look it at the front view, you will see z sub 1 uh is just a dot. Okay. Just a dot. While x sub 2 is an arrow pointing upward. So let's see an example. Let's cite an example. Okay. So let's say this is z sub 1. This point is z sub 1 at front view. Okay. At front view, this is z sub 1. Okay. At front view, this is also x sub 2. Okay. X sub 2 is pointing upward. So, at front view, they are not intersecting. If I extend z sub 1 or if I extend x sub 2. Okay. So, to comply with rule 3, the x-axis and the z-axis, the z sub 1 and x sub 2 should intersect whatever the view. Okay, whatever view you are looking at. Example, at this first example, okay, the x-axis and the z-axis are intersecting, okay, intersecting whatever view you are looking on it. Okay, but this one, if you look at the front view, z sub 1 is just a point, while x sub 2 is an arrow pointing upward. The same if you look at it at at a top view. At a top view, x sub 2 is the point, while z sub 1 is the arrow pointing downward. Okay, at the front view, z sub 1 is an arrow pointing to the left, while x sub 2 is an arrow pointing upward. They look like intersecting, but they are not intersecting at the front view and top view. So if that happens, it means x sub 2, okay, does not comply with rule 3. If something is not complying with the rules of the frame rules, we need to do something. So in rule 3, we have here rules for complying rule 3. Okay. So this is how you do the rules for complying rule 3. Okay. First, you need to rotate the axis until it hits the other. So what we need to do is let's try to rotate the axis. Okay, the axis who have problems here. So the problematic axis is the x sub 2. We need to rotate it to intersect with z sub 1. So let's try to intersect it like this. Okay. Now, as you can see, when I rotate it, When I rotate it, and the axis of rotation is at the center, okay, it's already now intersecting with Z sub 1. Okay, but when X sub 2 rotates, Z sub 2 should also rotate. Okay, because they rotate at the same axis. Okay, at the axis of frame 2, at the origin of frame 2. If there is something you moved on your frame, you should go back to rule 1, then rule 2, then rule 3. Okay? You must observe if this new uh this new drawing of your frame complies with the first two rules. So in rule 1, the z-axis must be the axis of rotation for twisting or revolute, or the direction of translation for a prismatic joint. So this is a prismatic joint. So this should be pointing here, not upward. So it does not complies with rule 1. So if it does not complies to the first two rules, you should return it to its original position. Okay? If the rotation is not good, you will do the second one. So the second one is to translate the axis until it hits the other. Okay. What does the second rule means is you can translate. You can translate the axis. You can translate the axis sidewards, upward or downward, or frontward or backward. Okay? So we can translate it and translate it up to the origin of Z sub 1. Okay? If now they have the same origin, as you can see, Z sub 1 is already intersecting with X sub 2. Okay? So X sub 2 is also already intersecting with Z sub 1. Then, because you moved X sub 2, you need to also move Z sub 2. So we will move Z sub 2. We will translate it. Okay? At the direction you translated X sub 2. Okay? So let's translate this to its new position. Okay. So again, if you move an axis or you move the frame, you must go back to the first two rules and see if it follows the or if it still complies with the first two rules. So Z sub 2 is still at the axis sorry, at the direction of translation of the prismatic joint. Okay, it's still at the direction of the prismatic joint. Then rule 2, X sub 2 is still perpendicular to Z sub 1 and Z sub 2. Okay. Next. So now X sub 2 is complying with rule 3. If X sub 2 is already complying with rule 3, now we can leave it like this. Okay. So remember class, before translating the axis, you must first try to rotate it. Don't translate it. Okay, don't translate it the first time you do the compliance to rule 3. What you need to do, or the step by step of this compliance, is do first rotate. If rotate doesn't, if the rotation is not good, then do the translate. Okay, that's the practice. Step 1 is the rotate. Step 2 is the translate. If the step 1 is not good, do the step 2. Okay, now let's go to the last frame, the end effector frame. So at the end effector frame, x sub 3 must intersect with z sub 2. So what we will do here is we will extend z sub 2. Now, as you can see, it intersects with x sub 3. So x sub 3 complies with the rule 3. So if everyone is complying with rule 3 now, we can go to rule 4. Okay, we must follow the right hand rule for the y-axis. So let's choose green. Oh, sorry, not print. Shapes. Okay, so for the first frame, z, y. So z is upward, x is rightward, so y is backward. Okay, so let's make this thinner, not thicker. Okay, so this will be our y sub 0. Next, for our z sub 1 is pointing to the front, x sub 1 is pointing to the right. So the y-axis is pointing upward. Okay, so this is y-axis. So let's leave it like that because y-axis is the least important. Next is y sub 2. Okay, z sub 2 is pointing to the right. X sub 2 is pointing upward. So y sub 2 should point to the front. Okay, so this will be our y sub 2. Next, for the end effector frame, so z sub 3 is pointing to the right, x sub 3 is pointing upward, so y sub 3 should point to the front. Okay, so this is our y sub 3. Okay, so remember this compliance to the rule. Okay, so this is the kinematic diagram for spherical manipulator. Okay.